Hi, my name is Matt Austin, and in this video it is my pleasure to introduce SOTA RC products, and the first product to come under the SOTA banner, the position sensitive damping system. It is absolutely feature packed. There's been really no stone left unturned in terms of looking at all the individual components that was needed to create a completely new, innovative system, patent pending. It's taken close to 2 years to get here, hundreds of prototypes, thousands of dyno tests, different drivers from some of Australia's fastest to some of the slowest over different types of tracks, and all of that has contributed to what you see here. I'm very pleased to present it. It has taken some time, but the end product has been worth the wait for me. It's taking our existing dampers or shocks, you can call it whatever, to another new level. There really is. To try and compare this with the old it's difficult. Our existing orifice shocks, they're probably this next year they'll celebrate their 115th birthday. They are ancient. They're old technology. Modern full-size vehicles moved away from orifice-style pistons some 50 years ago. There are probably many people watching this video that weren't even born when these things were made redundant. It served us okay, but there are a lot of limitations with these systems, and I certainly through this journey have found every one of them. I'll start from the top. The bladder itself is something you're probably familiar with. Obviously, this is just for the displacement of the oil, but it is made of a firmer nitrile butadiene rubber, or NBR. It's a tear resistant, and it is firmer to allow for those to compensate for the higher forces. It is, some of the manufacturers use the NBR type of material. Silicon wasn't considered. Well, it was for a moment until I realised, or one of the test drivers told me how much it swells, and it's just not compatible. In a compatibility chart, silicon rubber is only considered fair in terms of its compatibility with silicon oil. The silicon oil migrates into it and it swells. So that was not chosen for that reason. There's a unique take on rebound. So additional rebound type of damping or adjustment is in this package. It's unique because of the unique style of second chamber system that was needed to get the performance needed. You can see those holes. There's three. The one on the outside is for just to hold the shim stack in place, or the shim. And those three can be adjusted with these small grub screws. You can get up to 30% more damping speed over your compression side with these holes. The piston itself, as I said, it's a very unusual sort of kidney shaped, D-shaped. It's an organic shape for a reason. It's a CNC machined acetal, very strong. You can see the recess there. That was done on purpose to maintain a thickness, so it's incredibly strong. It won't break. And because it's a much smaller area. Now, SOTA stands for state of the art, and the idea behind state of the art was to create unique, innovative products, but apply a level of research or testing that I don't quite see as someone who drives these myself. I don't see into some of the product development, to be brutally honest, and I wanted to change that. To develop this product, I used a dyno extensively and the use of a dyno in making a shock is as needed as a tape measure is needed for a builder to build a house. You just cannot do this without a dyno. It was great at testing some of the commonly held beliefs out there in RC world. Some of those beliefs have been adopted from the full-size shocks, which don't quite apply to what we have here, particularly around how the traditional orifice-style pistons in the full size would get into a quadratic type of damping curve or a turbulent curve. We don't get that. That were one of the myths that was sort of tested and proven not quite to be the case. It is a different type of damping curve. We cannot compare these type of orifice pistons to our bigger brethren for various reasons. And the other idea is that if you have a bigger area of a shock, you get different or better damping. Not quite the case. Having a bigger area means you're now displacing more oil. The more oil you displace, the higher the velocity because you're pushing more volume. This smaller piston doesn't have to pump as much oil, but it still provides the same level of damping force, which I'll get to. And therefore, because it's not having to push as much oil, it's a lower velocity. And then with this second chamber system, it's lower velocity again. All of those factors contribute to a much more balanced system and creates virtually zero fade. The existing orifice pistons were removed or phased out through innovation in the shim stacks and what have you, because of the high damping forces they would create under very high speeds, but also because of the issues with cavitation and aeration of their shocks. They create a very high pressure above the piston head and a very low pressure below. Pressurizing them mitigated that somewhat, but we don't have that type of ability here. Shim stacks are problematic in trying to make them simple to work on and really trying to have some sort of multi-level Ohlins, Fox shock type technology here. It'd be prohibitively expensive, difficult to work on, and we needed a simpler solution, and particularly one that would be backward compatible. And that was one of the key criteria. I wanted something that it would lift the performance, but also it's accessible to every serious driver. And as you can see, these sleeves drop into an existing shock. You still keep your shock, and with a few, remove your piston and you're ready to go. That said, not every make and model is being accounted for just yet. Unfortunately, I need the actual vehicles to measure up and making sure these slots are positioned in the right areas. It's not done by guesswork, and that's why I only say at the time of this filming it's S-Works, Associated, Kyosho, Techno, and the Techno guys are pretty lucky because I think they use the same shock bodies across the buggy platform and the truggy. Well, they do, so they can actually use the ones that will be available from day one on both platforms, which is great for those guys. All right, the washer has under the forces that I subjected these to, and I had them up to 40 kilograms or 90 pounds. It's a lot of force, something you wouldn't be able to actually produce in normal race conditions, certainly unless you dropped it off a building. The washer would start to roll over a bit. The actual pistons themselves can deflect a little and push on the washer. In this particular case, the internal diameter of this piston is a fraction bigger than the actual shock shaft, and if the washer itself failed, the piston would fall. So I needed to create a stronger base and a base that would help. Again, with this smaller surface area and low overhang, it would be a much more stable, consistent feel under very high damping forces. This is CNC machined. It's a stainless steel 304. It's a 1.2 2 millimeters thick, which means it's about 5 times stronger than a standard washer. It will not bend, and it's a great platform for the piston. It can handle very high loads. There's the grub screws. Nothing really to see there. They're a very good grub screw, but still a grub screw. The unique part, the sleeve. Started here, not state of the art. This highlighted many issues with our current monotubes. This would fade after 2 or 3 laps. On the dyno, it certainly suggested it looked okay at lower speeds, but once you get up to the higher speeds, it had issues. It only got into a prototype stage, a very rudimentary prototype stage, but it failed. It failed miserably. That particular style, it didn't remove the issues that you have with these orifice pistons, and it just wouldn't. It certainly wasn't state of the art, and certainly something I just did not want to market. It just doesn't work. Maybe I'll do a debrief of sorts of all the different prototypes, and again there are hundreds of them, and there are many fails, but the learnings from it helped with developing this. And the main call out for this was the vacuum that this created by having a high damping in the top end of the zone and the bottom end of the zone. It highlighted the issue you get with vacuum and aeration, cavitation, and that brought about this big change of this second chamber system. And it is unique. It creates a more balanced pressure between the top of the piston head and the bottom. It's a sort of a symbiotic turbocharged type mouse on a wheel, you name it. But the way the oil flows, the oil is pushed up. Again, there's no holes in compression. It's pushed up and back around and up below the piston, and that cycle type of effect really contributes to that zero type fade, or very, very low fade. For the first time ever, it's position sensitive and tunable. So each one of these inserts have been dyno tested to a certain piston feel, and you can now tune for jumps, bumps, landings, the different type of track conditions and the driver wants. It is such a leap on what we've got. It really works well because of this low velocity and still high damping. It is a more linear type of feel. It's more consistent, so it will stay linear longer. And that's probably another thing I found with the orifice pistons, and particularly the oil types we use in 1/8. There is a low speed, high speed type of damping. Low speed might be less than 100 millimeters per second, which is fairly slow. Penske shocks, for example, would say anything below 3 inches per second is low speed, which is on a full size shock quite slow. I still haven't done the full research on what would be low speed for us, but for argument's sake, if it was 100 millimeters at this point, these orifice pistons will stay linear right up to, say, 0.5 meter per second, and that's really quick. It's well over what would be a low speed event, and it is getting well and truly into that high speed type of damping. So even if you're doing quite fast, that is still what we would call a linear or laminar flow. But the inserts, because of the low velocity, high damping, it will maintain that curve into much higher velocity. So it is more consistent because of the architecture you see there. On the actual inserts themselves, they have been dyno tuned. They're at this stage, and this is a system. This system is not changing. I'm not changing this sleeve. Taken 2 years already to get here. I'm not about to change it. Version 2.0 is not anywhere on the horizon. The system stays. There may be additional inserts, and the big call out there, it won't be coming over the next couple of months, but a big potential here is these inserts, these 3 inserts are a hard plastic. They're injection molded. They're incredibly strong. They're a very nice fit into the actual sleeves themselves, where you can adjust the damping now in the 3 zones. But just on those inserts, if we could possibly make some in the future that might sort of fill in some gaps, I'll go through where they sit in these particular piston types. But the actual material itself might be flexible, and in flexible it might have a certain design that would mean it would potentially fold over at a certain velocity, and for the first time then we would get both position sensitive damping and also speed sensitive damping. And the position sensitive was a priority. Most of the big off-road extreme type vehicles place a greater emphasis on position sensitive damping. It is crucial for their that type of racing. You know, the Baja type races, King of Hammers, trophy trucks all use this. King shocks, Fox shocks have position sensitive damping products. They're probably the 2 big ones I can think of. And speed sensitive, you could probably argue, is more for, say, on road, but there could be speed sensitive in this in the not too distant future, and it will be compatible with this system. You can just take that insert out and put a different type of insert, a new flexible insert, and you'll get then the position sensitive damping as well as perhaps speed sensitive. There are a lot of options with this system, and we can take our driving or our racing to another new level. So with these inserts, we've got, these have been dyno tuned to mimic the feels, and they're categorized because another myth, I guess, is there's a lot of perception out there that some of these pistons have very different feels. According to the dyno, they don't really. Not to the point where they're, say, 5 at the best 10% of a variation between the two. Therefore, I wasn't going to make a light purple and a dark purple, or 3 colours of blue here, light blue, dark blue, midnight blue. It wasn't really needed. And when you consider the number of oil viscosities you have also, there are a lot of combinations. You could conceivably have 50 odd combinations to sort of tune your shocks, which is a lot. Adding more only adds more to the sort of the headache you could have. Therefore, it was deemed you've got 3. You've also got a no insert, so conceivably you've got 4 tuning types. The purple is a very consistent feel with the 8x1.3, and these are Kyosho pistons, and a 5x1.5, very similar feel. Not a lot of margin, that would make me want to make those a different color, as I said. The blue, 20% extra damping, and that has a similar feel to a 5x1.4, 8x1.2, and a 6x1.3. These ones are almost twins. They are very similar across different oil viscosities, different speeds, both low speed, exceptionally high speeds. They are very, very close. The red is 30% more. So with purple, say if that's the baseline, you've got 20% more damping. With the blue and with the red, it's another 30. So call that's 50% on the purple. And that is a very similar feel to the 8x1.2 angled. And the angled, because of it is angled, nothing magical. It's just the oil is it's a longer pipe, more friction, and you've got just a bump up in damping. So what that means is you could have your shock absorber, and you may want to have a nice sort of compliant ride in your ride zone. and you'll have a purple, which is your 5 by 1.5. It'll move nice and free here. But when the piston, and it's position sensitive, so where the piston rides into, say, your top out zone where your shocks are fully extended, it'll be a lot firmer, 50% firmer at the same velocity. So you'll load up. So it means your landings could be a little bit firmer. It means your tyres will take on a bit more force. You can probably get on the trigger a little bit more and give it a rip. As the piston then moves up, you'll go into that nice comfortable ride zone. And then in say compression, from your ride zone into what I would call a bottom out zone, where you're getting close to your chassis. Your chassis is effectively a bump stop. That is necessary for racing buggies. You cannot remove that bump stop. I'll go into that in the installations. But in that top out zone here, the bottom out zone, it will be firmer again, and you get a different sort of ride quality there too. As I said, you've got a lot of adjustment here. It is very unique, and again, this lower velocity that this creates is you just don't get the fade. This can last a 45-minute main, 60-minute main comfortably in any conditions. We've had the prototypes running in Jakarta recently, very high heat, very high humidity, and the report back was there was just really no fade. One of the test drivers who has come on board is known in Australian RC racing is Caleb Noble. I think he's at this time he's a factory driver for Techno, very fast young driver, and he won the Vic titles recently with this system. After the 45 minutes, he came out and said the car felt great. It felt as good as it did the last 10 minutes as it did at the first 10 minutes. And he could have quite comfortably have run another 15 minutes. He actually wanted to run another 15 minutes. It was a very tight technical track. You had to keep on it that whole time. There was no real rest breaks. And he just finds that this particular system, he can drive fast, but it is just a lot more forgiving. It's just an easier drive. Arguably, in order to maximize your handling of your vehicle, your suspension and your tyres are the most important components. Tyres, probably the most important, but very close behind is your shock absorbers. And as I said, we've got 115-year-old, or we did have 115-year-old type of technology. The tyres have moved on. They're pretty good, but these dampers needed improvement to catch up. And now we have something that is truly unique, easy to work on, and you can be faster. Anyway, I hope you've enjoyed this video. As I said, I'll do an install video. There's a few little nuances in there that I didn't want to quite put on print. And yeah, but I hope you enjoyed the video. And if you do watch the installation videos, hopefully I answer some other questions. But if I don't, I'm happy to answer any sort of questions on the system itself. The orifice pistons, not so much. But yeah, I'm very pleased with this. Just on that, the product itself will only be available online for the moment. I'm doing that because I just want to see how things pan out with sort of American markets or EU markets or Asian markets as well. If it's beneficial to the consumer, then I'll look at basing something that would be beneficial to you guys. Anyway, if there is any other questions, feel free to drop me an email. But until then, I'll see you on the next video. Thank you for watching. See ya. Bye.